Hey, good evening, everyone. Welcome to physics lesson. Wow, whose camera? Green color one. Okay, my name is Mr. Chu. Okay, today we'll be starting our lesson on O-level physics. So I'll be using the O-level physics syllabus to for this lesson. Okay, and today is Monday, 16th of January, and welcome to the class. Okay, I've taken down the detail of all of you, what you're studying, so I roughly know your background. Okay, so let me first share with you what is physics. Okay, what is physics? Okay, those that were with me before would have seen mind map like this, correct? Okay, so physics is one branch of science. Okay, it's one branch of a science. Okay, that actually is a body of knowledge. Okay, that describe the order within our nature. Okay, so with for many of you, okay, except for Siren, Siren still studying normal science, right? Okay, for many of you, you all have been introduced that in secondary school, it be introduced that science can be broken down into physics, chemistry, and biology. Okay, so let me talk about physics first. So basic physics actually is the basics of most of the sciences. But the fundamental of physics, okay, you need to know your mathematics because a lot of physical concept, okay, are based on mathematics. Okay, you need to know your mathematics well. How are things related? Okay, so the mathematics is the fundamental knowledge that all of you need to know. Okay, and then among the three sciences, okay, physics actually is a more basic science compared to the others. Okay, so the physics are the laws that actually describe how the universe works. Okay, I use the word universe and not the world because it actually dictate how things work, okay, in this world, okay, in this universe. Okay, then chemistry is about chemistry is about things, okay, that when how they behave, how things react when they put them together and so on. Okay, then for biology is about okay, it's a science about life. Okay, about life, things that is life. Okay, things that can actually reproduce, that can move by themselves, can react to changes and so on. Okay, so these are the three different branches of science. Okay, we have one more student that just came in. Okay, welcome, Brian. Can you please on your camera whenever you're in class? Thank you. Okay, so let me continue. Okay, so physics is actually the basic fundamental of science. Okay, a lot of things that you're going to learn in chemistry and bio is built upon physics because how things move is physics. Okay, and then you also learn how a living thing move, correct? Okay, so a lot of fundamental is all based on physics. So physics actually is more in the past. Okay, physics is the part of science that every student will learn. Okay, but now if some of your friends that's only learning chemistry and bio, they might see some gap in their knowledge because they are not taking physics. Okay, so let's look at this mind map. Okay, look at this mind map in O-level physics. Okay, there's those that studying A-level will be also very similar. Okay, O-level physics, you'll be physics itself is broken down into 5 branches. Okay, so the schedule that I'm going to share with you all will be these 2 lessons for this month. It will be just 2 lessons. It will be on measurement. Okay, today I will talk about the theory, and then the next lesson we'll talk about partial question. Okay, so if some of you that are on trial today, okay, I will say that if you want to really see whether is this lesson effective, okay, at least please come for my because okay, you do attend my my lesson on Newtonian mechanics. Okay, why do I say so? Because for at least for these two topics, the first two topics, kinematics and dynamics, is very, very conceptual. Okay, it's not just about memorizing. If you remember, you might not understand. But if you understand, it should be quite easy. Okay, so those who are on trial, okay, if you think the first lesson might not be as useful because it is just about physical quantity, do try out at least a lesson on kinematics or dynamics. Then you see whether am I able to value add to you. Okay, one more student. Let me just update. Okay, so everybody is here. So hello Ryan. Sorry, Brian. Hello. Ray Hong. Okay, my name is Mr. Chu. So can you all, both of you please on your camera once you're in this class. All right. Okay, so today we'll talk about measurement. So measurement is not much about physics. It's just something that it is just a standard that all of us need to understand and appreciate so that the rest of the physical topic, okay, will fall in place. Okay, so the conceptual part of physics will start from the second topic, which is kinematics, which, okay, some of you might have just started. Is it confusing for you? And then because it becomes very confusing after the second and third topic, then you'll give up on physics. Okay, and that is what I want to make sure that it doesn't happen to you. Okay, so the second and third topic is actually very, very important. It either tells you, okay, either let you believe that you like this subject or you don't like. And because these two topics might be hard to understand, some teacher might not teach this part first. Okay, some teacher might just jump to thermal physics first. Okay, so maybe before we continue, can I have Brian and Ray Hong, can you share with us right in the chat which school are you from? Are you taking O-level or N-level physics? And are you taking pure or combined science? And lastly, what are your last year result? Then the rest of you, can you share with me in the chat what is your school, which topic of physics is your school teaching you now? Okay, for Syrian, maybe you can share with us, share with me what is your science teacher teaching you now. Okay, can you share in the chat group? Thank you. I have asked some question. Yeah, you're typing out now. Okay, Ishan, so what do you think of kinematics? Is it a good start? Okay, the rest of you, what you're learning now? So your school, Ishan, your school is starting on Newtonian mechanics, not skipping to other parts. Brian, you are doing pure physics or combined physics? You're in O level or A or N level or A level? And Brian, what is your Sec 2 result? Okay, thank you, Ray Hong. Okay, Ray Hong, how's your Sec 2 result? Okay, the rest of you are Zachary, Siren, and Zixuan. Can you share with me what is the topic that your school is teaching you now? Okay, for your physics or for your science? Siren, are you there? Brian, can you please on your camera? Zachary, also please on your camera. Hello. Okay, Zixuan still on the first topic. Okay, so I asked some question, you all are not answering me. Okay, Ray Hong, thank you for your answer. Seems like you're doing okay. Ray Hong, what's your school teaching you now?
Like the topic.
Hmm?
Like you mean topic
Which topic?
Measurements.
So measurement finish.
Yeah. No,
Okay.
like now doing measurements.
Okay, so it's still on the first topic.
Yeah.
So haven't touched the next topic yet. Okay.
Mm.
Hey, Zachary, your school is starting very fast, kinematics. Okay, so if you're like to, okay, most students will either like or don't like physics based on second topic. Okay, so if you, yeah, I will hope that all of you stay here. Okay, at least still kinematics topic and see how I can help you understand the topic well. Okay, so let me continue. Okay, so I will not talk much about the branches. So for this month in January, just 2 lessons. Next lesson, Chinese New Year. Okay, 新年快乐. There'll be no lesson next week. Okay, so today I'll talk about the theory on this topic. Then the next lesson, we'll go through some past year question. Then on February, okay, then we'll start with kinematics. Then that will be the part which I think will be important for all of you. Okay, if you are think that is confusing in school, I promise that I will explain it in an easy manner for all of you. Okay, that is for February. Okay, so this is the what we're going to study this year. Okay, let's continue. Okay, so for today, it will be a little bit dry. Okay, however, I would like you all to yeah, so whatever that's important, okay, I think today you will just treat today like a revision because your school already almost finishing this topic. If not, you have already finished. Okay, so let's continue. Okay, so the first part, called the first branch or the first section is called measurement. Okay, so everybody, all the scientists in this world, we need to standardize how we measure things. Okay, if you measure your height using the number of coins versus me measure my height using the number of shoes. Okay, so all of us might have different ways of measuring height. Okay, so for this topic, we are just trying to understand, okay, how do we actually measure things? Okay, how do you actually measure things? So in this session, we will actually learn the base physical quantity and units. Okay, so there are actually 7, okay, base quantity. Okay, in the whole of science, there's only 7 base quantity, and the rest of the quantity are all derived based on these 7. Okay, do you all remember what are the 7? Okay, and then in science, okay, so for example, if you're going to be an astrophysicist or an astronomer, you're going to use a quantity that is going to be very, very big. Okay, so you're going to use big prefixes for your measurement. Then for those that are doing maybe like nanotechnology, okay, your things that you're going to deal with are all very, very, very small. Okay, so the numbers will be all very small. So you're going to use certain prefixes that is easier to describe rather than typing 0.000000001. Okay, so this is the first topic is just to standardize with everybody. So when we talk about science, everybody are all in the same page. Okay, so for the whole universe, things can be very, very big in space, and things can be very, very, very small as a particle. Okay, so this topic will actually describe all this. Okay, so for section 1, okay, section 1, what are all of you are required to know? Okay, first of all, you should know what is physical quantity. Okay, so basically, since we are here, let me just start. What is the definition? Okay, first of all, physical quantity got 2 parts. Number 1, there is a number. Okay, hold on. Okay, what's happening? Okay, first of all, there is a number. And secondly, there is a unit. Okay, so what does this mean? So physical quantity, let me give you an example. Okay, we can call this length. Okay, length is a physical quantity. Okay, I can say that the length of something is 1.8 meter. So the 1.8 is your magnitude, and your meter is your unit. How many of you remember my lesson in primary school? Do you remember I said something like this before? Quantity is meaningless if there's no unit. Who remember one? Raise your hand. Or give me a yes reaction. You don't remember? All quantity has no meaning, okay, without a unit. Okay, those with me in primary 5 and primary 6 science, I think I have kept on mentioning this, that quantity must have a unit. Okay, so basically, the first part we have just finished. Okay, all physical quantity, okay, has a numerical magnitude, which is the number. Okay, there's a number, how big and how small it is, plus a unit. Okay, without a unit, for example, I say length is equal to 1.8. It makes no sense because it could be 1.8 cm, it can be 1.8 yard, it can be 1.8 inch, 1.8 kilometers. Okay, so the unit is very, very important. So do remember, okay, even in your mathematics or even in your chemistry and bio, if you have you need to write down any physical quantity, it is 2 parts. There is a number and a unit. Clear so far? Okay, if you understand this, the first part, give me a yes reaction. Well, some of you know your head. Give reaction, you forget to use Zoom already. Okay, all okay? Okay, so I explained what's the meaning of physical quantity, so all okay. Okay, next thing. Okay, I haven't finished the physical quantity yet. Okay, so I also mentioned that there are 7. Okay, there are 7 base unit. Okay, there are 7 base quantity and their unit. Okay, so what are the 7 base unit? So these are the unit that cannot be broken down further. Okay, is that clear? Okay, so there are 7 of them: mass, length, time, current, temperature, and amount of substance. Okay, a bit wrong. I only mentioned 6, right? What's the last one? Okay, there's one more later. I'm going to tell you which one is it. Okay, but for all of you now, okay, basically the 5 important one, the 5 important one is mass, length, time, current, and temperature. Okay, then in chemistry, you're going to know about this thing called the amount of substance. Okay, the 7th one is the luminosity, how bright a light is. Okay, that one is the 7th one. Okay, so there are 7 base quantities. So all other quantity will be based on these 7 quantity. Is that clear? I'll give an example. Okay, you all learn in primary school speed. Okay, so speed is not a base quantity. Okay, speed can be broken down into distance over time. So can you see over here? Distance is the same as length, which is the base quantity, and time is also a base quantity. Okay, so the physical quantity speed is called the derived. Okay, the basic one is the length and the time. Okay, so length and time cannot be broken down further. Clear so far? Okay, so you understand about this 7 base quantity. Okay, in physics, you don't need to know the 7 one, the number 7. Okay, but you need to know this 6. But in the real physics, there's actually one more, which is the luminosity of light, how bright the light is. Okay, that one will not be tested. Okay, you need to know there are 7, but of the 7, the 5 important one is mass, length, time, current, and temperature. And all other quantity will be based on this. All the quantity you're going to learn, whether is it speed, velocity, acceleration, density, okay, your weight, okay, your force, okay, all the other from quantity that you're going to learn can all be broken down and made up by these 5 quantity. It's just like the basic alphabet, there are 26 of them. Okay, in this case, for physics, there are 7 basic quantity. All other quantity will be based on these 7. Is that clear? Okay, if you understand, give me a yes reaction. Hello. Give me a yes reaction if you understand. If you don't understand, give me a no reaction. Thank you, Siren. Well done. The rest of you, do you understand? If you understand, give me yes reaction. Hello. Thank you, Yixuan. Thank you, Zixuan. Thank you, Rui Hong. Okay, so far. Okay, now I'm going to talk about the next thing that you all need to know is the SI unit. Okay, so just now I remember I told you all about height. If your height is 1.8, it means different thing to different people. Some people use meter, some people use feet, some people use yards, some people use light year and so on. Okay, so to standardize everything, every quantity that you learn, there will be a standard unit. Okay, we call it the SI unit. So based on the 7 basic unit, those in bracket is the SI unit. So those that I'm going to underline is the SI unit of the basic quantity. Is that clear? Okay, so for example, speed. What is the SI unit for speed? Okay, length is in meters. The time is in second. So the SI unit for speed is meter per second. So this is the SI unit for speed. Not kilometer per hour, but meter per second. Is that clear? Okay, because the length, the SI unit for length is meter. The SI unit for time is second, as you can see over here. Okay, so therefore the SI unit for speed will be meter per second. Okay, not kilometer per hour, not miles per hour, okay, not inch per cm. Okay, is that clear? So all the SI unit will be based on the unit that you see here. Any question for me so far? Okay. Okay, so these are the things that I hope that I have tried to make it clearer to you if you are still not so clear. Okay, well, maybe you can share with me lah. Up to now, I've talked about the blue and the red. And you have learned this in school so far. Have I value add anything to you? If I value add something, write in the chat 10. If I value add nothing, write 0. If I value add a bit, write 1 to 9. So give me some feedback. Have I been value adding, or so far I've just doing simple revision? You already know this very well. So give me some feedback. How much did I help you understand so far? Or how much you already know? Then I can go a bit faster. So can you type in the chat how much have I helped you understand better so far? 10 beings, a lot. 0 means you already know. So can you please give me some feedback? Wow, Brian says 0. I'm very sad. I should move faster. Well, then after that he said he have not learned anything, but say I teach good. Wow, thank you, Brian. You know how to make me feel very lousy, then make me feel very good. Okay, Zachary says that I have helped you understand 8 to 9. So your school teacher did not teach you properly, or you never listen in class. How about the rest of you? Have so far, am I helpful for you? Okay, Ray Hong put me 5. Thank you for your feedback. How about the rest, the ladies? Ladies? Siren, in Sec 2, do you learn this before? No? Or you all haven't learned this before? Or you all learn the basic thing? I don't think you all learned this before, right? Siren. Yeah, but it's not so hard for you lah, as a Sec 2 student. Okay, Yixuan and Zixuan, how about both of you? So far, are you okay? Hello. Thank you, Zixuan. Hey, I ask you give me rating and you give me thumbs up. Okay, let me continue. Let me talk about prefixes. Remember, I mentioned earlier on, things can be very, very small, like atom. Okay, very, very small. And things can be very, very big, like the earth. Okay, so instead of writing things like 0.000001 meter, for example, or instead of writing, okay, a very, very, very big number, okay, so for us physics, okay, and even in mathematics, you're going to learn this thing called prefixes, okay, where we use a letter, okay, to indicate sub-multiple or multiple. Okay, so all the things that you're going to learn will be you'll be jumping in the power of 3. Okay, what do I mean by that? Okay, so there are from very big, very big will be, let me see, giga. Okay, so you need to know from giga 10 to the power of 9 to 10 to the power of 6 to 10 to the power of 3. Then normal is 10 to the power of 0, which is 1. To 10 to the power of -3, -6, and -9. Okay, so can you see this number? The power actually jumped by 3. The bigger the power, the bigger the number. The smaller the power, the smaller number. Okay, so instead of writing 90 or 10 to the power of 9, okay, so for physics or for mathematics, we actually use a letter to represent. Okay, so for 10 to the power of 9, we use giga to replace. Okay, who just left the class? Okay, Zixuan just left. Okay, we use giga to replace 10 to the power of 9. Okay, so for 10 to the power of 6, we use mega. Okay, 10 to the power of 3, we use kilo. Then this is a normal, so there's no prefix. 10 to the power of -3, we use milli. You know millimeters, we use milli. 10 to the power of -6, we use micro. Okay, micro. This letter here, if you want to pronounce it, is called mu, M-I-U. Okay, this letter is called mu. Okay, so we use the prefix mu. Okay, this character is called mu, but we call this micro. Okay, this is called milli, this is called kilo. Okay, so this letter here is called micro. This symbol is pronounced as mu. Okay, then we go down even smaller. We got 10 to the power of -9, it'll be nano. Okay, up to here, is there any question? So these are the prefixes that you all need to know, not just in physics, but in your mathematics as well. Okay, in mathematics, you need to learn this. Okay, let me report that Siren left the class. Not Siren, Zixuan left the class. Okay, so these are prefixes. So instead of not writing something like this, okay, instead of writing something like this, I can actually change this to 1. Okay, So 1, 2, 3, 4, 5, 6. So 6 minus 6. This will be, I can just rewrite it as 1 micrometer. So this number here is the same as 1 micrometer. So the 0.0000, all this part, okay, can be replaced by micro. Is that clear? Or before that, you can also change it to 1 times 10 to the power of minus 6 meters, and then you become 1 micrometer. Clear so far? So talk about this one. This one is actually very big. So there are 3 here, there are 3 here. So this is the same as 10 times 10 to the power of 6 meter. So 10 times 10 to the power of 6, you can see, sorry, 10 to the power of 6 is this one. So it's the same as 10 megameter. Is that clear? Okay, so the part that I'm going to circle is the prefix. So this is the prefix. Okay, the letter that I circle is the prefix. Okay, so because in science, you're going to deal with very small things like atom in the nanoscale, or very big thing like Earth, maybe to the giga scale. So instead of writing very, very small number or very, very big number, you just change them to the prefix. Okay, so this you need to remember. Any question for me about this? Okay, but you look at the syllabus, there are 2 more prefixes that you need to know. Okay, you can see here, centi and deci. Okay, so centi is the 10 to the power of minus centimeter. Yeah, 10 to the power of minus 2. And deci is 10 to the power. Sorry. Yeah, centi minus 2, deci 10 to the power of minus 1. Okay, so you need to know this extra 2. But these 2 are hardly used, except for centimeter. Okay, then centi and deci are hardly used. Okay, the rest are used very often because they're all jumping the power of 3. Okay, just that you also need to know these 2, but these 2 are hardly used. The rest are the more important one. Okay, so far? Can? Okay, up to here, the blue, the red, and the green. Any question about for me? Okay, I'm just showing you what you need to know based on these topics. Okay, and then I'm just showing you these are what you need to know, and I'm just teaching from here. Later I'll show you some notes. Okay, so the last 2 parts, scalar and vector. Okay, this I will use the notes to explain scalar and vector. What are the difference between scalar and vector? And I'll give you an example of them. Okay, and then you also need to know by using graphical method how to add 2 vectors together. Okay, as you go to A level and so on, you can use a calculating method. Okay, you need to break down into X and Y axis or even Z axis, then you add them together. Okay, so why might this one become so small now? Hold on. Okay, let me just clear the whole screen. Okay, so we need to know how to add 2 vectors together, and there's 2 methods I'm going to share with you all later. Okay, or maybe share with you all next week. Okay, next thing, you also need to know how to measure time and length. Okay, so these 2 I'll be talking more about it next week when we see sample question. Okay, then in practical, you also need to know how to use this equipment. Okay, so far this is what you need to know, okay, when you prepare for O-level exam. Okay, any questions so far? Okay, so for length, okay, you need to know how to measure length using things like tape, rule, micrometer, caliper. Okay, these are some of the measuring tool that you need to be familiar with. Okay, then for measuring time, okay, you need to learn how to measure time, such as a period of a pendulum, okay, using stopwatch and so on. So you need to know what's the meaning of one oscillation, what is the meaning of period. Okay, so I'll be going through this using the notes. Okay, so before we take a very, 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 very short break, any question for me? Okay, yes or no reaction. Thank you. Any question for me? Okay, why is there no reaction from your one? Okay, okay, have all of you received this notes? Okay, this was shared last week. Okay, I think you all should have. If you don't have, you ask from your parents again. Okay, so we're going to go through these notes. If you have the notes, whether in e-format or printer, you can also put it out in front. So this one I'm going to share with you all. Okay, these are all the topics of science. Okay, so let's revise again. Okay, first of all, physical quantity. Okay, physical quantity has a numerical magnitude and a unit. So let me just explain and emphasize again. Quantity is meaningless without a unit. So remember, all quantity, please do write down the unit. Okay, then in science, there are 7 base quantity. Okay, 7 base quantity. This one you do not need to know. Okay, this one you just need to know in chemistry. In physics, not very important. Okay, so basically, these 5 are the important one. Okay, these 5 are the important one. Okay, so you need to know these 5. What are the base unit? Okay, so the length is in meters, the mass is in kg, the time is in second, current is in ampere, and the temperature is in Kelvin. Okay, Kelvin. Okay, so the misconception that some of you might have is, okay, degree Celsius is not the SI unit. Okay, degree Celsius is not the SI unit. Take note. Okay, the interval of degree Celsius and Kelvin are the same. Okay, however, if you want to do calculation, we use Kelvin. Okay, we don't use degrees Celsius. Okay, so far. Okay, then there's another thing that a bit funny. Why is it that in kilogram there is a prefix? Okay, so the kilogram is the SI unit, not the gram. Okay, gram is not the SI unit. So it's a bit confusing. Okay, for all the unit, the one that is 1 meter, 1 second, 1 ampere, all these are the SI unit. The only thing that is not is for mass. The mass SI unit is 1 kilogram. Okay, not 1 gram. Clear so far? Okay, so these are the 7 basic quantity that you all need to, okay, not 7. You need to know 6. Okay, the luminous intensity you need to know. The amount of substance you need to know only in chemistry. Then the main thing is these 5 you need to know. Clear so far? Okay, then another thing is for SI unit. Let me share with you. This notes is not correct. So if you have the notes with you, okay, things like ampere, Kelvin, it should be small letter. It should be small letter. Okay, all these should be small letter. Okay, ampere and Kelvin are named after a scientist. So when you want to spell out the unit, it's all in small letter. But for the SI unit, it is in capital letter. Okay, so for ampere is capital A, but for you want to spell out ampere is small a. Clear? For the unit of temperature, it is capital K, but when you spell out Kelvin, it's a small k. Okay, so the notes here is not correct. And whether is it capital or small letter is also very important, because big and small letter can mean different things. For example, small k means kilo, big K means Kelvin. Okay, big A is ampere, small a is what? I think small a is acceleration. Okay, so you must also be very, very mindful that for unit as well as quantity, okay, whether is it capital letter or small letter, is very important. Okay, so okay, let me continue from here. Length, there is also this thing called symbol. Symbol is the meaning of symbol means what is the short form for that quantity. Okay, so sometimes as a scientist, next time you got a lot of things to write, you do a lot of research, a lot of experiment. You're not going to spell length all the time. Okay, so the symbol for length is a small l. Symbol for mass is a small m. Symbol for time is a small t. Okay, symbol for current is a capital I. Okay, so you all just take note. Symbol for temperature is a capital T. Okay, so you all need to know what are these are the symbol for the quantity. Okay, any question about this so far? Okay, so whether is it a capital letter or small letter, you need to be mindful as well. So for a start, there are so many quantity to remember. There are so many unit to remember. Okay, so it may be a bit confusing at first, but if you keep on using and using, then it becomes second nature to you all. Any question for me? Okay, so we talk about the base quantity. Base quantity are quantity that cannot be broken down further. Okay, that cannot be broken down further. Clear? Okay, y'all give me a minute. Let me do something. Okay, any question for me? Okay, so these are base quantity that it's just like a Lego. They are the base quantity. Okay, so the rest of the quantity they're going to learn are all derived quantity. They are all derived quantity. So for example, area, the symbol for area is capital A. Okay, basically is length times length. Okay, so the unit will be meter square. Okay, so meter square is not the base SI unit, but meter square is a SI unit for area. Okay, but it's not the base unit. These are the 7 base unit. Okay, so meter square is the SI unit. So cm square, kilometer square is not SI unit. Only meter square is the SI unit. Because length is based on meter, so you use meter square. Okay, the short form for volume is capital V, which is length times length times length. Okay, so same thing, this is meter cube. Okay, the short form for speed, for now, just remember it as S, small s. Okay, so the formula is distance divided by time. Okay, so your formula, your unit will be meter over second. Okay, do you need me to explain what this -1, -3 means? Okay, for O level, there is no need for you to write ms -1. Okay, it's perfectly okay to write meter per second. In your O level exam, all your unit will be like this, meter per second, not like this, meter second -1. Okay, however, when you advance to A level, okay, they will start to use unit like this more often. Okay, because it's easier to manipulate lah. But like this, it's harder to manipulate. Understand so far? Okay, so density, the symbol for density is rho. What is rho? Rho is RHO. Okay, this symbol is called rho, pronounced as rho. The formula is small m over big V, mass over volume. So mass is kilogram, correct? Volume is meter cube. Okay, so your formula, your unit for density will be kilogram per meter cube. Okay, so in O level, it is acceptable to write it this way. Okay, but if you go up to A level, you need to write it like this. So far, any question for me? I'm just revising. So I mentioned the example of speed earlier. Okay, so this is the example appeared again. What other derived quantity are you aware of? Have you learned force? Have you learned forces? Yes or no? Have you learned forces? Can you give me some feedback, Ling? Hello. Type something out, Ling. Asking you a question. Okay, so let me move on to prefixes. Prefixes. Okay, the important things are The important one are the multiple of 3. So the multiple of 3. These are the, okay. Terra, not important in secondary school. But you want to know, you can just take note. Okay, so for the small one will be the -3, -6, -9. So those that I take are the more important one. Okay, so are the more important one that all of you need to know. Clear so far? Okay, so the deca, the deci, centi, and the hecto, okay, not important. Okay, but you all need to know these two as well. Okay, but the important one are the two ticks. Okay, those that I did not tick, there is no need for you to know. Clear? Okay, so I mentioned this before. This is pronounced as mu. Okay. Okay, so example, there are things like, for this example, right, you can have kilometer. Okay, we can have megameter. We can have gigameter. Clear so far? Okay, so when you see K, it means 10 to the power of 3. You see big M is 10 to the power of 6. You see big G is 10 to the power of 9. Okay, big M, big G. You need to be very clear because there's small m. Okay, there are small m and things like that. Okay, same thing. The important things will be the 10 to the power of -3 and -6 and -9. So for example, millimeter. Okay, you all are familiar with this. So when you go even smaller, you have micrometer, and then even smaller, nanometer. Okay, so when you see the letter here, the small m, the small mu, and the small n, these are the prefixes. So let me just make it a bit clearer. Those that I'm going to box out are the prefixes. Understand? These are the prefixes. So it can be a prefix to any of these. Okay, it can be kilometer. It can also be kilogram. Okay, it can also be kilo ampere or kilo Kelvin. Clear so far? Okay, so these are all prefixes, and these are the unit. Okay, the M is the unit. So for all these example, I'm using length as an example. Is that clear? Okay. Okay, let's continue. Okay, hold on for a while. Let me look at the syllabus. Scalar and vector. Okay, let me talk about scalar and vector first before I talk about this. Okay, scalar and vector is not shown here. Okay, let me just talk about scalar and vector. Okay, if you all want, you all may want to just write down. Okay, what's the difference between scalar and vector? Okay, so scalar is a quantity. Okay, we have learned quantity, right? With just the magnitude. Okay, whereas for vector, it's the same quantity, okay, with magnitude and direction. So there is a direction added to it. It is something very new. Most of the quantity that you all learned before Sec 3, right, are all scalar quantity. You don't even bother whether the quantity has a direction. Okay, so most of the quantity you all learn are just scalar quantity. Okay, but moving to Sec 3, you know that there is a group of quantity, not just having a size, but also have a direction. Okay, have you all learned this in school so far? Okay, so vector is a quantity with direction. Okay, the important word here is direction. Clear? So what are the example of quantity with direction? Okay, let me explain to you all. Okay, you're going to learn this in kinematics a bit. Okay, so in chapter 2, you will learn about length. Length is just from length is a scalar. It's about how long the thing is. But for a length with length or distance is a scalar. Okay. But for a distance that has a direction, okay, we call this displacement. Is that clear? Okay, it's the same thing as distance, just that this quantity has a direction. Clear so far? Okay, distance has no direction, whereas displacement has direction. Okay, let me write down the short form. Short form for distance is D. The short form for displacement is S. A bit confusing because small s is also used for speed. Clear so far? Okay, the next quantity I'm going to talk about will be speed. Okay, speed itself is a scalar. Okay, there is no direction to it. Okay, just remember there's no direction. In chapter 2 onwards, I'm going to explain the vector part a bit more. But just remember now that speed is a scalar that has no direction. Whereas the quantity of speed that has direction is called velocity. Okay, velocity is the same thing as speed, but it has the direction. Okay, the short form for velocity is V. Okay, so those of you that are going to learn kinematics chapter 2, okay, the teacher will talk about velocity, displacement, very common. Okay, so there is a direction to all this. Okay, another example will be acceleration. I will not talk about that. Okay, I'll not talk about that. Maybe I talk about a bit more. Time. Does time has direction? Does time has direction? What do you think? Yes or no? Does time has any direction? Okay, Brian asked a question. He still don't understand what is the meaning of direction. Okay, so I give one example. In a track and field, okay, track and field, if you were to run, okay, the blue disc, if you were to run from here to here, okay, so the blue color is your distance. That's how much you run. Is that clear? You don't care about which direction it is, but that's the distance you run. Okay, Brian, is that okay? So let me use another color. I use black. Whereas for displacement, this is the displacement. Okay, you start from this point, you end at this point. Your net distance is this. So this black arrow is your displacement, and the direction is in the direction of this arrow. Okay, so even though you run halfway, your distance is the blue color length. For your displacement is this length plus the direction of this vector. Can I use another example? Force. You all learn force in primary school and in lower sec. Okay, force can have force number 1 here, can have another force number 2 here. So there are two forces. Okay, so force is a vector. So I want to put here, I can put here. Force is a vector. Force short form is capital F. Okay, so force is a vector, and why is it a vector? Because it has a direction. Where's the direction? For force 1, the direction is to the right. For force 2, the direction is down. So there is a direction. So force is a direction. Is that clear? Because there's a direction of the force. Whereas things like time, mass, if you have learned in primary school, mass is the amount of substance in the body. It's how many things that are inside there. So how many things are there inside? There's no direction. So mass has no direction. So mass is a scalar. Same thing for time. Okay, same thing for time. Time has also no direction. So time is a scalar. Okay, so Brian asked another good question. Why does distance has no direction? Okay, distance is basically what is the length overall that you have moved. So the direction keep on changing, but what you're interested in is the total distance or the total length you cover. Okay, it's a total length you cover. Okay, so that is the why it doesn't care about which direction you're moving. Okay, so therefore distance is under scalar. But if you care about the direction, even though you run from left to right, okay, displacement is just from left, the starting point and the ending point. You only care about starting point, ending point, and then you draw a straight line. So this point A to point B, this whole length here is your displacement and the direction is from left to right. Brian, did I answer your question a bit better or are you still confused? Okay, thank you, Brian. Okay, so Yishan asked me, explain velocity again. Okay, so I'm using distance and displacement to explain, okay, what's the difference between scalar and vector. Distance has no direction, so it's just distance. Displacement has a direction from left to right. So that is why it's called vector. Okay, so Isha asked me, what is velocity again? Okay, so for speed and velocity, for now, just remember that they are the same thing. Just that for velocity, there is a direction to it. Okay, let me explain one more time. Let me clear up. Okay, scalar and vector. So we talk about speed and velocity. So they are the same thing, but for velocity, it has direction. Okay, so when you talk about speed, you don't care about which direction you are moving at. It's just how fast you are moving. Okay, so the definition of speed is how fast you're moving. But that's not how you need to remember in school. The proper definition of speed you learn in chapter 2 is called the rate of change of distance. Okay, the proper definition of velocity is the rate of change of displacement. Okay, but let me use a layman term to explain between speed and velocity. So for speed, you can be running zigzag. Okay, how fast you run, that is your speed. Clear so far? You don't care which direction you are running. Okay, whereas for velocity, when you're running from left to right, you care about the direction. Is that clear? Okay, Yishan. Okay, for velocity, you care about the direction. Because when you, okay, for example, this box or this car is moving from left to right. Maybe there's engine, the force is pushing it from left to right. Okay, so you talk about speed, you don't care about the direction. When you talk about velocity, okay, you know that this is moving to the right. You care about the direction, it's moving to the right. Understand so far? I give another example. Okay, for example, you're holding a string with a ball, and this ball is turning, you're rotating the ball in circle. Okay, the ball is moving at a constant speed. If the ball is moving at a constant speed, okay, it means that the ball is moving at a same rate of change of the distance. Okay, it's moving it's actually moving, let's say fast. Okay, in one round. Okay, actually moving fast at a constant rate in one round. But the velocity will be different. Why? Because at the top point, the direction is here. The direction of the ball is here. At the point here, the direction is down. The point here, the direction is to the left. And the point here, the direction to the top. Okay, so for this example, as the ball is moving at a constant speed around in a circle, its velocity is changing all the time. The magnitude is the same. Let's say the value, for example, the speed is 4 meters per second. So as the ball is moving 4 meters per second in a circle, okay, the velocity, there's two parts, right? Sorry, the vector, there's two parts. There is a magnitude, which is the size, and there is a direction. So the magnitude, okay, the velocity, the magnitude is the same. It's 4. All around this circle is 4. But the direction keeps changing. At the top is to the right. At the right side is moving down. At the bottom is moving to the left. At the left side is moving up. So the direction keeps on changing. So in this example, when the ball is moving in a circle, the speed remains constant, but the velocity continuously changes. Are you confused? You understand the meaning of velocity now? Okay, so for Yishan, velocity is the same thing as speed. Just that velocity has one more component to it, which is the direction. You must add a direction to it. You should okay? Can? Okay, so that's the difference between scalar and vector. So any quantity that has direction, okay, will be under vector. So I give you some example. Displacement is a vector, velocity is a vector, acceleration is a vector because acceleration has direction. Okay, just now I talked about force. Force is a vector because force has direction. Okay, and then weight. Weight is a force. If you all remember, weight is a force. So weight is also a vector. So all the things that I mentioned here, they are all vector because they have direction. Okay, things like temperature got no direction, right? Temperature will be scalar. Okay, mass, how much thing there is inside, there's no direction. So it's all scalar. Density is also a scalar. Okay, so ask yourself, if the quantity has direction, like force, you'll be a vector. Clear? The only thing that is a little bit, maybe you're not very clear now will be, for distance and displacement, there's a difference. For speed and velocity, there is a difference. Okay, for displacement and velocity, they are the same as distance and speed. Just that for displacement and velocity, there is a direction component. Clear so far? Can? Is that okay? Okay, all of you, is that clear now? Some school or some teacher will not talk about scalar and vector until chapter 3. Okay, but in our syllabus, it's mentioned in chapter 1, so I just cover first lah. Okay, but the main thing you need to know now is that vector has direction. That's the main concept you need to know. Okay, as we move forward, we will talk more about speed lah, we talk more about velocity lah, displacement. We'll talk about that more in chapter 2 and 3 and so on. Okay, but for now, just remember, vector has direction, whereas scalar has no direction. Understand? Ken, is that helpful? So that is what you need to know today. Vector has direction, scalar has no direction. I gave some example, okay, but just to help you understand the idea. But the main thing you must get away from today is that vector has direction. Okay? So let me talk about adding vector by graphical method. Okay, this one you also need to know. Let me share with you now. Okay, so this part will be taught by a lot of teachers in chapter 3 under forces. But let me just talk to you here. So for example, there is this object. This object, which is a big red circle. Okay. There are two forces acting on it. Okay, so you all have learned forces before. There's force 1 here, and there's force 2 here. Okay. Where is my force 2? Okay. Agree with you the force. Okay. So I just give an example. There is force 1 here, and there's force 2 here. Okay. Okay, let's say this is me lah. Then one of you pull me to the right. Then the other person pull me to the bottom, to the down. Where will I be moving? Can you tell me where will I be moving? You all will know, right? I'll be moving somewhere in the bottom right direction. Correct? Okay, so for how do we add these two forces? They are two-way. They are two-way. So let me explain the first way. Okay, the most school will teach you is the parallelogram method. So basically, draw a parallelogram based on the two forces. Understand? So there's one force here. Force 1. Can you see force 1? Okay, let me see whether I can copy the force. I cannot. Let me try again. Cannot. Okay. So basically for parallelogram method, okay, so let's say this is the two same forces. Okay, force 1 is here, right? What you need to do is to construct a parallelogram. So I move the first force here, I bring it down. Okay, then I draw, then another force down here. Okay, so these two are the same, right? I do the parallelogram here. So can you see here? I have a parallelogram. Okay, and my resultant force will be from the starting point to the opposite end of the parallelogram. Okay, so my resulting force will be like this. Let me show you. My resulting force will be from the starting point to the ending point. Okay, so by this big arrow is my resultant. Is that clear? Okay, so this is a very precise way of drawing. When we draw like this, the graphical method, you make sure that you must draw your parallelogram precisely, because whatever length that you measure here will be the magnitude of this vector. Clear? So this is vector 1, the force 1 is vector 1, force 2 is vector 2, R is your resulting vector. So you must be very precise. Your parallelogram must be drawn perfectly. And then this is the graphical method of drawing. I use another example. Okay, this body here. So I have another vector. Okay, I make it a bit different. This vector go up. This vector go up. And another vector. Okay, maybe go this way. Can? So I got two vectors here. So how do I draw? What will be the resultant force? Okay, so basically, if I were to draw, for example, this one, let this be vector 1, and this be vector 2. I draw a similar parallelogram, same length. Okay, and then I draw another one here. Can you see? The length is the same, the direction is the same. And my resultant, okay, my resultant would be like this. From the starting point all the way to the ending point. Is that clear? Okay, so this will be my resultant vector. Okay, so for adding of two vectors, you can use the parallelogram method like this. Understand so far? So this is the parallelogram method. You need to be very precise. You need to bring your construction set and draw a perfect parallelogram. So these two dotted lines that I draw must be the same direction and length as the original two. You form a parallelogram and then you draw the resultant force. Okay, so this is very important. So why is it important? Maybe when you draw V1, you let 1 cm represent maybe 10 Newton. Okay, so this is your scale. To find the resultant, you just need to measure the length of this. If you draw perfectly, you measure the length of this, and based on the scale, you can find out the resultant force based on the two blue arrows. Understand so far? So are you clear about the parallelogram method? Can Okay, so in example, in question, okay, you need to construct properly. So I'm happy to see that there are questions from Brian. Continue your question, Brian. So let me talk a bit more. So this is the parallelogram method. Brian, so for example, in exam, they may tell you that force 1 is 10 Newton east. Force 2 is, let's say, 8 Newton south. Okay, so Brian, so you use a scale. Maybe you use a scale of 1 cm represent 2 Newton. So when you draw force 1, okay, when you draw force 1, this length has to be 5 cm. When you draw force 2, this is 4 cm. So this length has to be 5 cm, and this length has to be 4 cm. So you draw very precisely. So once you draw your force 1 and your force 2, you complete your parallelogram, then your resultant force is this. And then use a ruler to measure. For example, you don't quote me, just give an example. The length is 7 cm. Then you go back to your scale. Then you know that your resultant force is 14 Newton. You understand what I mean? So that's how you calculate based on the graphical method. You have to decide your own scale. A scale that is suitable, that is not too big and not too small. Can? So that is the graphical method lah. So the scale has to be, you have to come up with your own scale. Sometimes the question may ask, but most of the time you have to come up with your own scale. And when you draw something like this, okay, whether it's in practical or in your exam, your whole drawing cannot be less than half the length and the height. So for example, you got this paper, exam paper, right? Okay, your whole drawing, for example, this drawing here, this is Y and this is X. You're a bit screwed up. This paper, okay, should be less than 2Y. This paper should be less than 2X. Meaning that this drawing has to be more than half the width and the height of the space. Okay, so based on that, you determine your scale. Understand? Okay, so this is how you add vectors using the parallelogram method. Next week, we'll go through some example. Okay, but the concept will be like this. Okay, the second one will be clearer because it's not straight. It's based on some angle, so you can see better. Clear so far? Okay, the second way, just to touch on a bit, the second way of using a graphical method is called the tip to tail method. Okay, so I use the second example here. I draw V1 first. So I draw V1, I move to here. So basically, if there's only V1, this red dot will move to the tip of the arrow. Clear? Then your V2 is going down, right? Pulling the thing down, but this dot is now on the right side. So what do? You put the second force on the tip. The tail put on the tip. That's why it's called tip to tail. And then your resultant force will therefore be from the starting point to the ending point. So this is the tip to tail method. Same thing, you need your construction set to draw properly. Okay, so which method do you all prefer is all entirely up to you. Most school will be teaching the parallelogram method. Okay, but if you think that tip to tail makes sense, you can also use that. But the idea is the same. Basically, they are both the same thing. Okay, they are both the same thing. Why I say so then? Can you see? Basically, I'm just drawing a triangle, which is half of the parallelogram. Okay? So this part, if your school have not teach, at least today I share with you first. When your school teach chapter 3, you understand what is the adding of two vector. Is that useful for you? But the whole idea, does it help you understand so far? Basically, it's just draw a parallelogram and your resultant force is just from a starting point to the opposite of the parallelogram. That is the whole concept. Then after that, you just need to practice, need to know how the scale, how to draw, and then what need to measure. And then because this is a vector, your answer should have also a direction. Okay, I did not put in the direction. I put here 14 Newton because based on 7 cm at this scale. But you also need to describe the direction of this. So how to do the direction? You can actually, like, for example, if this is 30 degrees, you can say that it's 30 degrees clockwise of F1. Okay, so this is the direction that you need to explain. Okay, this resultant force has a magnitude of 14 Newton and it is 30 degree clockwise of force 1. So you need to actually explain the direction as well because this is a vector. Understand so far? Okay, the last part, maybe I just go through very, very quickly. And then I will emphasize that on question next week. Okay, so how to measure length. Before you measure length, you need to know that you should avoid parallax error by positioning your eye right directly over your the eyes must be directly above the scale marking. Okay, if you are seeing from the angle, you'll likely see a parallax error. Understand so far? Okay, and then another thing that you all also need to know is this thing called the zero error. Okay, zero error. So for example, when you close, okay, when you close vernier caliper, for example, it doesn't show zero. It doesn't show the exact zero. So there's an error to it. So you need to actually offset the error. So we are going to go through this example next week, because now already 9 o'clock. Let me just go through very quickly. Okay, so for all of you, you need to be very good with at least a few measuring instrument. I think measuring tape and meter rule should be no problem. Okay, so what you need to know will be things like this. The vernier caliper. Okay, your school will have taught you. I will not go through the detail. We will go through the question and I'll see whether you understand. Okay, and I believe most of you will have learned this in school, vernier caliper. Maybe you'll ask me, you have anything that you're not sure about step 1 to step 4? Ask me now. Okay, I'll not go through this. I'll just go through the question to test whether you understand. But if you have problem understanding what is all this here, can you ask me now? Any question about vernier caliper? Any question? Okay, nobody say any feedback, so I'll just move on. We'll just go through some question next week. Okay, then so we talk about zero error. When for vernier caliper, when you close the caliper and it shows zero, there is no zero error. There's no need to do any correction. But when you close, can you see here? When you close, it's already show that it's positive 0.03 cm. When your final reading, it will be actually 0.03 bigger. So you need to subtract 0.03 from your reading. Understand? So for negative zero error, when you close, it already show that it's less than 0. So when you take a reading, you must compensate it. You must correct the reading. You need to add 0.03 to your reading. Okay, that is a zero error. We'll go through some example next week. Are you clear about zero error? Or are you confused? Any of you confused? Please ask me now. Anybody, one of you need me to explain any of this diagram? Ask me now. I can explain. If not, we will go through the question next week and then we see how it goes. Any of you have any question about zero error? Can? Zero error is an error that you can avoid because it is already given to you. It's not a random error. Okay, zero error is not a random error. Same thing, parallax error is something that you can avoid. So that is not a random error. Random error are things like when you want to time yourself using a stopwatch, there will be random error because you will not time, you will not be exactly at the time when you press, you will not be exactly the same time at all time. So there will be some random error. Okay? Whereas for zero error, it is a bias error. Okay, if it's always positive 0. Okay, if your zero error is 0.03, all your reading will be always extra 0.03. So it is not a random error, it's a systematic error. And systematic error you can correct. Random error you cannot correct. So how do you actually deal with random error? How do you minimize random error? You can't correct it, but how can you minimize it? Can you share with me? For systematic error, you can actually correct it by offsetting the bias. But for random error, like your reaction time, how can you minimize random error? Okay, so for random error to minimize, you take more reading. Okay, you take more reading and then you take the average. Clear so far? Can? Okay, so for micrometer screw gauge, step 1 to 4. Any question for me? I will go through this next week. But any question about micrometer screw gauge? Any question? Anyone? If not, I'll just skip this first. Next week, we'll go into detail. We'll study how to read and then see whether you understand. But so far, when your teacher teach you about micrometer screw gauge, Any of you having problem, you can ask me now. Okay, if not, we'll deal with it next week. Anyone? Anyone? Okay, so same thing, micrometer screw gauge also has 0 error. We'll do this with this next week. Okay, so for measurement of time, we can either use a stopwatch or a ticker tape timer. Ticker tape timer. Do you know what's a ticker tape timer? Basically, the thing will actually press. There's a certain frequency you'll actually press every second. So a normal ticker tape timer, okay, in this case, you can see when it's very spread out, okay, very spread out like on the right side, it's moving very fast. When it's closer together, it's moving very slow. Okay, so this is how you use a ticker tape timer to measure the speed of the thing. Okay, the speed of your ticker tape. Okay, okay, the pendulum itself, let me just go through very quickly. The key things about measuring time on a pendulum, the key things you need to know is you don't use one oscillation. You use multiple oscillation like 20. Is that clear? Because one oscillation is very fast. So you take 20 and then you divide by 20. So that's number one. The next thing you need to know is that when you swing the pendulum, when you displace it, okay, it should be a small angle. You don't put it far away and then swing. You just displace it slightly. Let go, let it swing. Clear so far? Next thing, when you let go of the pendulum, you let it swing 1-2 times first. Then you start the time. You don't start the time when you let go. Let it move 1 to 2 oscillation. Then you start the time. Clear so far? And after you do 20, okay, you do that a few more times. Then you calculate the average. Okay, so what is one oscillation? One oscillation is from A to B and come back to A. So that is called one oscillation. Clear so far? Then, when do you start the stopwatch? Do you start at A or O? Where do you start? So, where do you start is also very important. Okay, we usually we all start at A. Okay, start at A. Why? Why not O? It's because when you're at A, the speed of the pendulum is the slowest, or actually is 0. As you move to O, you all learn about have you all learned in primary school about how you call that? Change of energy. Remember, change of energy. This has a lot of potential energy. Then you change to a lot of kinetic energy. Then you go back to potential energy again. So O is moving very fast. So for you to capture as it goes by O and capture it, it is very, very error prone. Okay, so the best time is to it's best time to actually start and stop is when the ball is the slowest, and it's slowest at A. Okay, so you start and stop the timing at A. Clear? Because as it goes all the way to A, at one point the speed will be 0. At that point you start. So let it go to B and go back to A. That is one oscillation. So to measure the oscillation or the period of the one oscillation, okay, what is period? Period means time taken for one oscillation. So the period, to measure the period, you do 20 oscillation, okay, starting from A, then you divide by 20. Understand so far? Here? Okay, so that is how you do a pendulum experiment. Okay, so to let me summarize a key point. First of all, you don't do one oscillation, you do many, 10 or 20. Clear? Number 2, you use a small angle. Okay, I want you to remember, use a small angle. And then you start and stop the stopwatch at the point where it's the slowest, which is at the A. Okay, not the O. O is when it's moving the fastest. They'll be not accurate. So you start and stop at A. Clear so far? So these are the 3 main points I want to highlight. Okay, I repeat again. You displace small angle, not too big. That's small will do. Number 2, do many oscillation and take the average. Because one oscillation is too short. And number three, you start and stop at the A. Understand so far? Okay, so talk about period is mentioned here. Okay, about today's lesson. Okay, Ray Hong, you are talking about digital. You mean digital stopwatch? Are you talking about digital stopwatch? But the process of doing the experiment is the same. You
No,
must use
I'm talking
small
about,
angle of displacement.
I'm
Sorry.
talking about the vernier. School is teaching the digital vernier and the digital micrometers program.
Are everyone having the same thing, the digital one, or am I outdated already?
I
Doing
don't
my
know, but my school is teaching the digital one. They never taught the like not digital one.
so digital is what? Just put together, you see the value, just use the value. Is that how you do it?
Yeah, digital is just like they will just give you the reading. You don't need to like read.
Can. How about the rest of you? Brian, Siren, Yishen, Zachary, and Zishen. Your school are using the digital one or the analog one for your vernier caliper and the micrometer screw gauge. Zachary is learning both. But for Brian, let me share with you. Sorry, not Brian, for Ray Hong, exam, when they show you all how to read the vernier caliper and micrometer screw gauge, you also need to know how to read them. So that one will not be digital. So you will still need to know how to read the drawing. So I'll show you some exam paper that you're going to see yourself. Can? Okay, so for measuring yeah, so for measuring a period of a pendulum, this is the three main point. Understand so far? And then the last part, this point is not important, okay, because they will not be tested, but just for your information, okay, they may ask you to do practical, your result will be like this. How fast the pendulum move in one oscillation doesn't depend on the weight, okay? It doesn't depend on the weight. Okay, it only depends on the length of the string as well as the gravitational force at the area. Clear so far? Can. Okay, so that's it for this lesson. Next week, you'll go through examples, then you will see it'll be a bit more clearer. Any question for me? Okay, so let me just give me 1 minute to go through the very important thing. Number one, pendulum experiment, small angle, do many oscillation, okay, and start and stop timing at the edge of the oscillation. Okay, number two, vector and scalar. Okay, the difference between vector and scalar is that vector has direction. Okay, that's what you need to know. Then yeah. Then you also need to know the prefixes. Then the 3, 6, 9, and the -3, -6, -9. Very important. You must memorize. Okay. You also need to know the 5 base quantity and their symbol. Okay. So that's the main thing that you all need to know today. Clear so far? Okay. So before we go, I think I will end my teaching now. I will need some feedback from you all. Okay. So I will give you all some question to write to me. Once I call your name, you may leave. So I want you to give me some feedback. Okay, just give me some feedback. One thing you learned today. Then Okay, these 4 questions. Once you answered me, I call your name and you may leave. Any of you have any question for me? You can also ask now. Okay, thank you, Si Ren. Si Ren, is this lesson useful for you? Okay, Yishen, thank you. You may go. See, Rena, is today's lesson relevant to you now? Because I think that your Sec 2 may not have teach so fast yet. Okay, so you type out your answer for 1 to 4. Once I call your name, you may go. Okay, see, Rena, I talk about next lesson now. Okay, sorry. Next lesson. So we rewrite your number 4. Okay, Brian, why everything 7? Everything you like 7. Aiyo. Okay, thank you, Brian. Happy New Year. Okay, Ray Hong, thank you for your feedback. Hey, number 4. So today you learn half. Okay, bye, Ray Hong, you may go. Happy New Year. Hey, Zachary, thank you for your feedback. You may go.
Bye-bye.
Bye, 新年快乐. See you. So how we come back next week? Next week. Okay, thank you, see you. Nice to see you again. Good night and goodbye.